Hi all, this is MathDOC. Under this session, we are going to discuss about rectangular Cartesian coordinate system. Rectangular Cartesian coordinate system lesson, very important lesson under A-level mathematics. Here we are going to discuss about straight lines, circles, and the fundamentals of straight line and circles comes with rectangular Cartesian coordinate system. First, let's see what is rectangular Cartesian coordinate system. You consider two perpendicular real number lines. These are real number lines. Horizontal one we say x-axis, vertical one we say y-axis. They are perpendicular. Then here the intercept will be 0, 0 point. We call the origin. And here real number line, point 1, 2, 3. Likewise, we can get coordinates. A minus 1, plus 1, plus 2, plus 3. This is rectangular Cartesian coordinate system. This axis we call x-axis, this axis we call y-axis, and here this point we call the origin. When you consider a point on this plane we call Cartesian plane, let's say point P, let this coordinate x comma y, then from the origin horizontal displacement we call x and vertical displacement we call y. Then here x, then here y, and especially this x is called abscissa. X coordinate is called abscissa. Y coordinate we call ordinate. Y coordinate we call ordinate. This is rectangular Cartesian coordinate system. And when you consider this system, rectangular Cartesian coordinate system, here x-axis, here y-axis, here we can see four sections. Here section 1, section 2, section 3 and section 4. Those are known as quadrants. Here we call first quadrant, and similarly here we say second quadrant, and here we say third quadrant, and here we say fourth quadrant. Those are quadrants. Then sign of the quadrants, when you consider the coordinate, consider here x-axis, y-axis. You consider a point P, x comma y. When this point in first quadrant, P is in first quadrant, then x value, y value both positive. In first quadrant, x value, y value both positive. When P is in second quadrant, somewhere here x value negative but y value positive. When this point P on third quadrant, that means this quadrant, both x and y values are negative. When x in fourth quadrant, point in fourth quadrant, here x value positive but y value negative. Those are the signs of coordinates in each quadrant. Let's move further. Under coordinate geometry, there are a few theorems. First one we call distance formula. Here we are going to discuss about distance to a point from the origin and as well as distance between 2 points. First one, consider this diagram. Here x-axis, y-axis, we call here origin and take this point P, coordinate x, y. And now consider this line segment, we call OP line segment, the point xy. Therefore here coordinates we can get as x and here this coordinate get as y. Then here x and y can be positive or negative because when P varies then x and y can be positive or negative. So when you consider this length, here this length we say x modulus. Modulus means only absolute value. We consider only value. And here this length we say y modulus. Then OP length equal by Pythagorean theorem modulus x squared plus modulus y squared root. Therefore we write here OP equal x squared plus y squared root. You can neglect modulus sign. We call distance formula. Distance to a point from the origin. And further, special thing, when you consider line segment OP, you take this angle theta. With the positive direction of x-axis, you take this angle theta. And then here gradient we say tan theta. Therefore, here gradient we write, we just denote by m equal y divided by x. We call gradient. Y divided by x. And let's move further. When you consider 2 points on this plane, that is second theorem under distance formula, distance between 2 points. Let's take this diagram. This is x-axis, this is y-axis. Take point, say here P1, x1, y1. Take here P2, x2, y2. Then let this line segment P1, P2. Now here this coordinate we say x1 and here this coordinate we say x2. Therefore this length we write x1 minus x2 modulus. We put modulus to get on the absolute value. Then here this coordinate we say y2. Here this coordinate we say y1. Then distance between these 2 points we say y1 minus y2 modulus. Now considering this right angle triangle, you can write P1 P2 length by Pythagorean theorem x1 minus x2 modulus square plus y1 minus y2 modulus square root. We call distance formula distance between 2 points. Then to remember P1 P2 length equal, you can remove this modulus, x1 minus x2 squared plus y1 minus y2 squared whole thing root. This is distance formula, distance between 2 points. X difference square plus y difference square root. So here also you take this angle theta. Therefore here this gradient we say tan theta. And further we can denote this one by m. Then tan theta equal y difference of x difference. y1 minus y2 over x1 minus x2 we call gradient. here you wrote here y1 minus y2 and x1 minus x2, and O m equal y2 minus y1 over x2 minus x1 also possible. When you start from second coordinate, then denominator also start with second coordinate. When you start with first coordinate in numerator, and denominator also will be start with first coordinate, that is gradient. Now you consider positive gradients m greater than 0, then line will be like this. So when you consider the angle theta, then theta in between 0 to 90 degrees, and when m equals 0, line something like this parallel to x-axis, then here theta value equal to 0 degrees. When m value equal to infinity, here infinity, then the line parallel to y-axis, then theta value equal to 90 degrees. Then m value less than 0, then we take here angle theta, then theta in between 90 to 180 degrees. Then remember, when gradient positive, acute angle with the positive direction of the x-axis. When gradient 0, it is parallel to the x-axis. When gradient infinity, it is parallel to the y-axis. And when gradient negative, it is obtuse angle with the positive direction of the x-axis. Those are the theorems with distance formula. Let's move further. Then let's analyze about section formula. Internal division. Consider x-axis, y-axis, then 2 points given here, P1, x1, y1, and here P2, x2, y2, 2 points given. I'm going to find a coordinate somewhere here. Let's say P, let x bar, y bar. Consider given P1 and P2 points. Then P1 P is to P2 ratio. Let m is to n ratio. Here m, here n. Then when finding the coordinate of P, you can consider here these two triangles. Here this triangle, here this one, and here this one. They are similar triangles. Therefore, here this length we can write y2 minus y bar. y2 minus y bar. And here this length we can write y bar minus y bar. The division that equal to m n over m. N over m. Now cross multiply my2 my bar ny bar minus ny1. Then subject y bar terms. Take my bar to the other side. Then my bar plus ny bar equal, take ny1 to the other side, my2 plus ny1. Take y bar outside, m plus n, my2 plus ny1. Then here y bar equal to my2 plus ny1 over m plus n. And similarly, here this length x2 minus x bar, and here this length x bar minus x1. That division equal to n over m. N over m. I similar triangles corresponding side ratios must be equal. Then simplify this. mx2 minus mx bar equal nx bar minus nx1. Then take this on the other side. mx bar plus nx bar equal mx2 plus nx1. Then x bar take outside. M plus n, mx2 plus nx1. Then x bar equal to now mx2 plus nx1 over m plus n, that is x bar coordinate. Finally, this point P we can directly write mx2 plus nx1 over m plus n. Similarly, my2 plus ny1 over m plus n. We call here distance formula, section formula, internal division. And here the way mx2 plus nx1 over m plus n. Similarly, my2 plus ny1 over m plus n. You need to multiply m with the non-related point, that is p2, then mx2 plus nx1 over m plus n, that is internal division. Then when doing sections, this section formula you can apply directly. You need to remember this one as a formula, and the pattern need to remember. That is internal division between 2 points. Now let's move further. Section formula, external division. Consider here point P1 given x1 y1. Here point P2 given x2 y2, and here this point we're gonna find it. Take this point P, x bar y bar. Now here ratios given from P1 ratio m, from P2 the ratio n. Then by previous theorem, external division theorem, you consider P point P1 as given and P2 need to find, that is internal division. Then here we can write this ratio m minus n ratio, Then by the previous theorem you can write x2 equal m minus n x bar plus nx1 m minus n plus n, ratio sum m minus n plus n. Now simplify this. mx2 m minus n x bar nx1. Now m minus n x bar equal mx2 plus nx1. X bar equal mx2 here minus nx1 over m minus n. That is for external division. Then previous case we got here positive plus value, but here the pattern mx1 mx2 plus nx1 over m minus n, mx2 minus nx1 over m minus n. Similarly, you write y2 coordinate here m minus n y bar by the previous theorem ny1 plus ny1 over m minus n plus n, ratio sum. Now simplify this, cross multiply. my2 equal m minus n y bar plus ny1. Now m minus n y bar equal my2 minus ny1. Then y bar coordinate my2 minus ny1 over m minus n. Then remember point P now equal to mx2 minus nx1 over m minus n, my2 minus ny1 over m minus n. here P point, that is external division of given 2 points. You need to remember this formula when doing questions directly. You can apply this one directly. The pattern, you remember this pattern, M multiply with non-related point. Here M related with P1 and P. Then P2 will be the non-related point. Then M x2 and N non-related with x1. Then M x2 minus N x1 over M minus N. M x2 minus N x1 over M minus N. Similarly, M y2 minus N y1 over M minus N. That is external division point. Now, the last theorem, area of a triangle. Area of a triangle. Consider this diagram. Here x-axis, y-axis. Here a triangle given. Point x1, y1, x2, y2, x3, y3. Those 3 coordinates given. Now, if we need to find the area of this triangle, here take this point x1, here x2, here x3, here y1, here y2, here y3. Now you need to remember, when you consider a trapezium, let this length h and here 2 parallel lines length AB. Then here area we write, area equal to half into A plus B into H. Half into A plus B into H. Then here the area of this triangle. First consider the area of this trapezium. Write it half into, here this parallel side length y1 plus y3, and here this length x3 minus x1, half into A plus B into H, half into y1 plus y3 times here this length x3 minus x1. And then take this area plus half into y3 plus y2 times this length x2 minus x3. Now consider here this area, that also a trapezium, half into y1 plus y2, here x2 minus x1. So first add first 2 trapezium areas and subtract third one, then we can deduce area of the triangle. Then when we simplify this, half common, take it outside, and to remember this thing easily, I'm gonna take x1 coordinate at a single term. Here x1 times y1 plus y3 there with minus sign, then minus y1 minus y3, and another x1 there, minus x1 with this one plus x1, then y1 plus y2. You can combine that. Then x2, here that's 1, y3 plus y2, and another x2 there with minus sign, y1 y2, minus y1 minus y2, plus x3, here y1 plus y3, and here x3 minus y3 minus y2. Now simplify a little, half into x1 times, you cancel y1, y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. We call here area of the triangle. And here these are coordinates, no? Then this value can be positive or negative, but area must be always positive. Therefore, you need to put modulus sign to get only positive answer. That is the area of the triangle. Area of the triangle. To remember this one easily, take these 3 points x1 y1, x2 y2, x3 y3, write as a cycle. Then remember area equal half into modulus x1 times y2 minus y3. Go this way, x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Put modulus. That is area of the triangle. So if you obtain this area as 0 value denoted by delta, if it is 0, then these 3 points must be collinear. Therefore say 3 points are collinear. Collinear, that means they lies on a line. They lies on the line. So triangle. And another important thing, area for quadrilateral. Area for quadrilateral. When you consider any quadrilateral, something like this. So when finding area, you split into triangles. You write area of this triangle and write area of this triangle and write area of this triangle and add all together to find area of the quadrilateral. That is the area of a triangle and the area of a quadrilateral. Those are the important theorems comes with coordinate geometry. So these theorems really directly related with straight lines as well as circles. So that's all about coordinate geometry theorem, coordinate geometry. Thank you for watching us, MathDOC.